will guide us regarding the testing of the hypothesis, which is the backbone of research work. When we are testing the previous research which has been done, which is related to the hypothesis aspect. So this is the main aspect which will took us to the research as well as conclusion, which is based upon the hypothesis. So as you are very familiar with Dr. Kirti Kamalja ma'am, who is working as the professor in Department of Statistics, School of Mathematical Sciences, Kavayatri Bahinabai Chaudhary, North Maharashtra University, Jalgaon. So I would like to request respected Dr. Kirti Kamalja ma'am to focus upon the testing hypothesis, and I would like to regret some. So ma'am, please, you can continue.
Yes, am I audible?
Yes, ma'am, yes.
Okay, yes. So we are going to talk about testing of hypothesis. And my objectives during this session, I want to make you aware about fundamental concepts of testing of hypothesis. Then I will be discussing commonly used terms like type 1 error, type 2 error, power p-value, which are very important to go for testing of hypothesis. And afterwards, I'll be talking about chi-square test of independence, t-test, and z-test with few examples and some methodology. So I'll start with example, because what is exactly testing of hypothesis, that must be very clear in the beginning. Instead of starting the theory and concepts, I would be going through one example. So look at the picture which I have included. This is one energy bar, and most of the time we can see the contents in medicine or even whatever chocolates or energy bars we are purchasing. So look at this particular energy gram, which is of 38 gram, and it is specified that this energy bar will contain 5.3 grams of protein, dietary fiber 3.0 gram, and so on. So actually, whatever is written over here, that should be true for the whole population, and for that purpose, most of the time some testing are done. So I have considered similar type of example, that labels on energy bar that claim that every bar contains suppose 20 grams of protein. So now food auditor wish to test this particular hypothetical statement that yes, every bar will contain 20 grams of protein. So for this, he or she want to use statistical tool. So she takes a random sample of 31 energy bars, but those samples will be taken from different stores randomly. Okay, the energy bar available to general consumer in the stores, that will represent now population for us, and we are taking random sample from the whole population. So the sample size may vary. So 31 energy bars are chosen, and now for all of those bars, the protein content is tested through lab, and these are the values for the grams of protein available in those 31 energy bars. Now, what is your hypothetical statement? Actually, here the consumer and producer, they are having particular relation, that consumer says that yes, 20 grams of protein is there, and consumer is using it with that belief. So here we want to test whether really the mean, we can say mean protein content is 20 grams or not. So here your opposite hypothesis, which is known as alternative hypothesis, will be the mean protein content is not equal to 20. So mu, this is the notation that is used for mean protein content. So see, we are going to use, obviously I got data and I'll be using software. So for this, because I know I will use t-test. So before performing t-test, we have to decide the level of significance. Level of significance, I'll be making it clear through next subsequent slide. But right now, level of significance is kind of error that 5% of the time my decision may be wrong, or what we can say that 95% of the time my decision will be correct. So that is the user or the t-test for t-test, whoever is performing, he is going to decide the level of significance, which indicate kind of assurance or error. So software will do some calculations based on the data that is provided, and non-statistician should look at the p-value given by the software. So here p-value is 0.0046. Now what is to be done with this p-value? So here the p-value is to be compared with the level of significance that we have decided. So p-value is less than the level of significance. So here what decision will be taking based on the data? The null hypothesis is rejected based on the data. What it means exactly? That we have sufficient evidence to support alternative hypothesis. So our conclusion based on this exercise, what is our conclusion? That mean protein content in the energy bar is not equal to 20. So either the label, see what action will be doing, either the label should be updated, that means it should be modified, or the production process should be improved so that the content of the energy bar will be exactly 20 grams of protein would be there. So this is what most of the time production processes or not only the industry, but most of the time social science people or management students, market research projects, they are interested in testing such hypothesis because they have to they want to gain assurance about the statements those are done about the product or product quality, we can say. And with this now, this was one simple situation where how we can use testing of hypothesis that I just demonstrated. But now let us look at what is level of significance, p-value, what is null hypothesis, what is alternative hypothesis. So all these things must be very clear to us, and how to set up the hypothesis, how to set up the level of significance, what exactly it means, what is p-value. So if these things we will be clear to the general user, then you can very easily apply the variety of tests those are available in statistics, because we are not actually, you are not expected, non-statistician is not expected to know all the things, but at least how to conclude, how to set up hypothesis, this is very important for all of us. So actually what is statistics? So statistics is branch of mathematics that transforms data into useful information for decision makers. So most of the decision, whether it is in industry or it is in market research or it is in social sciences or it is in applied sciences, some decisions are to be made. So based on data, we used to make decision, but for that we need some statistical tools. So basically statistics is divided into two parts, descriptive statistics and inferential statistics. So here actually our focus would be not on only on descriptive statistics, but we are interested in drawing conclusions and make decisions based on the sample data. So again we have seen two parts, but in inferential statistics also there are two types of inferences those are done, that is estimation of parameters and testing of hypothesis. So this second branch or second part is very applied, which can be used by even what we can say art side people also can use this testing of hypothesis if they properly set up the things. So now let us look at the commonly used terms before starting or before going directly for testing of hypothesis. So some phrases are already known to all of us, that is population. So after every 10 years, India used to have a population census. So what it means exactly, that each and every individual in India that will be considered as a particular respondent, and all the information related to that respondents will be collected through survey. So that is called as population census, but it is very much costly and nobody will afford such a cost, is very high cost it is. So most of the time, some decisions are taken on sample. So sample is actually the proportion, small proportion of portion of the population, which will be obviously representative of the population. Now, what is to be done with the sample? So statistical inference, it actually what it does, it generalizes some conclusions based on from sample, based on sample. Those are generalized to population. So that is our main objective when we use the concept of statistical inference. So parameter and statistic. Parameter is the particular characteristic of the population. For example, we can say height of the Indian person. We can say income of the particular individual. So this will be the characteristic which most of the time we are studying. It may be time required to swim 400 meter. So it can be any kind of variable which you are interested in your research. Now, there would be a difference between the things in statistics. Parameters are denoted by Greek letters, and parameters are going to be fixed while the sample-based quantities like sample mean, sample variance, those are going to change. So, in population quantities are fixed, while sample-based quantities are going to change. And this is what we study, the change in the sample, how it reflects in the population. So this is what exactly we are doing. So here you have the population. You have the population. From that population, we get sample. Then that sample gives us data. And from data, we have some calculations. From those calculations, we have some inference, and we talk about the parameters. So this is the process of sample and sample based inference. So we are doing this many times actually. So we are going to focus on confidence, not focus on confidence interval, but our interest is in testing of hypothesis. For example, here the proportion of adults with cell phone is 0.60. So this will be the hypothetical statement, suppose, and we are interested in testing this. So hypothesis, what is exactly testing of hypothesis and what is hypothesis? So actually hypothesis is a statement about the value of population parameter, and our particular objective will be whether to support that statement or not. So hypothesis is actually claim or assumption about the population parameter. Now, the hypothesis, they are popularly having two categories, null hypothesis and alternative hypothesis. So, look at this null hypothesis. The null hypothesis will be usually, because it is null, it is denoted by H suffix naught, H naught, and it is tentative assumption about the population parameter. For example, here I have one particular situation, that monthly average sale of particular product after launching advertisement and before launching advertisement, whether it is equal or not. So this might be our interest, that whether the advertisement is really effective or not, that we want to test, but will not set up the hypothesis. Null hypothesis will be always having the equality, that actually you will be interested in rejection of the null hypothesis or non-supporting the null hypothesis. So remember that null hypothesis to be set where equality is there. Now what can be alternative hypothesis? So alternative hypothesis is denoted by H1 or H of A, and it states that population parameter is different than the value of population parameter in the null hypothesis. That means whatever we have specified in the null hypothesis, it is different than that one. So that is your alternative hypothesis, and you just see that our alternative hypothesis is what the test attempted to establish. So actually our interest would be to establish the alternative hypothesis, not the null hypothesis. For example, we know that obviously after launching the advertisement, the sale of the product is going to increase. So actually mean sale after advertisement will be obviously greater than mean sale before launching the advertisement. So look at this situation that your alternative hypothesis will be mean sale after advertisement will be more than mean sale before the advertisement. So this is what we want to establish, but we are setting this in alternative hypothesis, not in null hypothesis. So one more example, suppose in a 20 to 74-year-old male population, the mean serum cholesterol is 211. Okay, so this is my guess or what I'm suspecting. So if you'll define that serum cholesterol is the mean parameter, so actually you are testing that H naught in null hypothesis, you are testing that mu is equal to 211, and your alternative hypothesis is mu not equal to 211. But now you can see that you can have three different ways of setting up the alternative hypothesis. That mu not equal to, you can set up as mu greater than 211. You can set up as mu less than 200. Depending on your interest, you can set up the alternative hypothesis, but your null hypothesis will be in terms of equality. Now, let us see one more example where now what is the situation? Mean cholesterol for hypertensive men. So obviously we know that general male population and hypertensive male population, those are different. So actually mean cholesterol for this hypertensive male population and mean cholesterol for general male population, that is going to be different. But what I'm setting in null hypothesis, look at this, that mean cholesterol for hypertensive male is same as mean cholesterol for general male population, while in alternative hypothesis I am including not equal to, the two means are not equal. So actually all these examples, what is my aim actually, that whenever you are going for your own research, your situation will be different, but you must be able to define proper null hypothesis and proper alternative hypothesis, and that's why you just go through variety of examples, then you'll understand it. Now look at this, that suppose one pipe industry producing company is there, and they wish to ensure that their average inside diameter, so main parameter is inside diameter. So here your inside diameter of pipe is 5 centimeter. So your null hypothesis is actually mu equal to 5. Now if, see, we can set up three different alternative hypotheses. So mu greater than 5, this will be referred as left-tailed hypothesis. Mu less than 5, this will be treated as right-tailed hypothesis. And both of these are known as one-tailed alternative hypothesis. Now apart from this, you can set up two-tailed hypothesis also, two-tailed alternative hypothesis, which is known as two-sided. So what is the two-sided hypothesis? Now you will include that mu is not equal to 5. So once you have null hypothesis, this one corresponding to that, we have to choose any one of these three. One of these three, not all. Whatever your interest, if you are interested in this or this or this, so for corresponding to this null hypothesis, you are going to choose appropriate alternative hypothesis. Now when to have that one? So if you want to show that population mean is less than the target value, then you will set up this hypothesis. If you want to establish that true population mean, that means mean inner diameter of the pipe is more than 5, then set up this one. And if you want to establish that the mean diameter is not 5, it can be more or less, so you will set up the two-sided hypothesis. So it depends on your situation in whatever problem you are having. In that problem, what you want to establish, accordingly you are going to choose that. Now there is one very common non-statistical testing of hypothesis we used to see in our day-to-day life or in movies also. So what is common in most of the movies, that one court case is going on and then the judge gives some decision. So that is a kind of non-statistical hypothesis. So look at that. Criminal trial is an example of hypothesis testing, but without test statistic. And what is actually, it is based on evidences. So in court, whenever the court cases are going on, evidence-based decisions are done. So what is the problem actually? In a trial, jury has to decide to support one of the two hypotheses. Now, what is the hypothesis actually? So whatever defendant is there, actually, we want to establish that defendant is guilty, but it is not included in the null hypothesis. It must be included in the alternative hypothesis. So your null hypothesis in court example will be the defendant is innocent, not guilty. While alternative hypothesis is the defendant is guilty. And you want to establish this particular situation. That means you want to establish the alternative hypothesis. Now, what is the exact scenario at that time? The jury does not know which hypothesis is true, because whatever defendant is there, the defendant can be innocent also, or it can be guilty also. So decision is to be made based on evidences which are presented in court. So this is now look at the decision. What happens exactly? Convicting the defendant is called rejecting the null hypothesis in favor of the alternate hypothesis. Now, see what it means. The jury is saying that when decision is given, jury is saying that there is enough evidence to conclude that defendant is guilty. So, based on evidences, the defendant is treated as guilty. So, evidences are enough to support the alternative hypothesis. This is the meaning of that. So, now here data, exact data is not there, but evidences are there. But this is a kind of real testing of hypothesis. In other case, when the judge is giving the opposite decision, if the jury acquits, it is stating that there is not enough evidence to support the alternative hypothesis. So jury is not saying that defendant is innocent, but what the jury is saying that there is not enough evidence to support the alternative hypothesis. What it means that the evidences are not indicating the respective alternative hypothesis. So that is why what in real life we used to come across the example of testing of hypothesis. So now what kind of testing of hypothesis will be having? So most of the time we'll be having test related to population mean. And in that case, we'll be using t-test. These are very commonly used everywhere. These t-tests are used, but obviously t-test, there are 3 different types of tests, and at which situation which t-test is to be applied, that is very important. So that those things we are going to make clear through this particular presentation. Now there may be the situation where you you are interested in testing the population proportion also. For example, I want to test, suppose my H naught is P equal to 0.20. So what is my P now? My P is proportion of diabetic patients in India. So what I want to establish here, that whether every 20 people out of 100 they are diabetic patient or not. So I want to establish this one. So many times you may be interested in testing the hypothesis related to population proportion. Other situation may be like this, that the diabetic patients in India, proportion of diabetic patients in India, is it same as proportion of diabetic patients in Japan? So this is Japan and this is India. So this is actually, again, it is hypothesis related to proportion, but you are having now 2 countries and you are comparing whether the proportions are equal or not. So most of the time, population mean is to be tested or population proportion is to be tested. So let us see how we can test. But before that, now whatever hypothesis testing we are doing, then there are going to be some errors, and those errors are known as types of errors are two types of error can occur from our side when we are testing the hypothesis, that is type 1 error and type 2 error. Now, you might have heard sometimes that type 1 error, which is denoted by Greek letter alpha, is also known as level of significance, or it is LOS, level of significance. Beta is another type of error, and it is known as type 2 error. But now 1 minus beta will be a correct decision, or it will be representing correct decision. So 1 minus beta will be power of the test. So these are the commonly used phrases like type 1 error or level of significance, and type 2 error, or it is related to power of the test. Okay, so these things, if you know what is how to choose alpha or what is exactly alpha, then it will be easy for you. Now see what exactly type 1 error and type 2 error are there. Now see here, let me have one example. Yes, so I'll write something here. Suppose here true decision or fact. What is fact actually? Suppose I'm suspecting that I got some symptoms of diabetes, so I want to check whether I am diabetes patient or not. So actually, your true or fact can be I can be diabetes patient or I can be non-diabetes patient. So this is the fact which can happen if I'll go for the test. So what I'll be doing if I'm suspecting whether I am a diabetes patient or non-diabetes patient. So I'll go to lab and I'll test my blood and I'll show the reports to the experts or medical experts. So now see what can happen based on my reports. Suppose I got reports, sugar in blood. I have one sugar in urine. So 3-4 things, my hemoglobin. These 3-4 things I have tested. Now I came to the medical experts, and now see what can happen. Really, if I have diabetes, and this is the decision given by medical expert. Suppose this is the decision given by medical expert. Now, if I am really having diabetes and medical expert is also saying diabetes, then this will be the correct decision. Now, if I don't have diabetes really, but my reports mistakenly are showing that the decision is given that diabetes, so this is the wrong decision. So this is something error is there. Okay. Then now look at this, that you have, in fact, you are diabetes patient, but the reports are showing that you are non-diabetes patient. So this is again one kind of error. Okay. And when you have no diabetes and decision given by medical practitioner is no diabetes. So that is the correct decision. Okay. So look at this, that this is correct decision is okay, but this is the kind of error and this is the kind of error which is very dangerous. Now what kind of danger is there? You can see that given that I was not having any diabetes. Actually, I was not having diabetes, but practitioner said that you have diabetes. So what kind of risk is there that I'll be starting the course for diabetes patients. I'll go for so many exercises. I will have sugar control plan, health plans, and so on. So this is dangerous. And look at this also, that I have diabetes, but the medical practitioner said that you have no diabetes. Okay. So this is also very dangerous, because even though I am having diabetes, the reports are showing that there no diabetes is there. So this is rather risky for that particular individual. So look at this scenario, that even though these errors should be as minimum as possible. So we want to minimize this error. So statistics exactly do this thing, that error should be as minimum as possible. So look at this, that H naught is
Kamalja ma'am. मॅडम म्यूट झाले आता.
मॅडमचा आवाज येत नाहीये सर.
हा मॅडम.
मॅडमचा माईक म्यूट झालाय वाटतं.
हा त्यांना फोन करतोय.
हो.
हा मॅम.
येस
audible. Now you are audible.
Okay. So we were talking about type 1 error. So type 1 error is probability of rejecting the null hypothesis when, even though it is true, we are rejecting the null hypothesis. That's why it is an error, and that is known as level of significance, which is actually false positive indication. Okay, so type 1 error it's very important for us when we'll be testing the hypothesis. We are going to take decision about this type 1 error. And type 2 error, look at this. So if you are going to appear for exam, then these two definitions must be known to you. What is type 1 error and what is type 2 error? So type 2 error is beta. So beta is probability of do not reject H0 given that H1 is true. I think H0 and H1, it might be clear to all of the participant. What is H0 and H1? Yes, anybody? H0 is null hypothesis. Yes, and H1 is alternative hypothesis. And what we want to establish? We want to establish actually alternative hypothesis. So null hypothesis may be like this, that your exam score, mean exam score will be suppose 15 out of 20, and your convener may say that your mean exam score will be less than 15 out of 20. So this is what you want to test for exam. Okay, now let us go further. So actually all these things are given in detail, that when we'll be setting up the hypothesis, I have considered the diabetes example, but now what will be your H0 and what will be H1? So if I'm going for test, if I'm suspecting that I can be diabetic patient, so my null hypothesis would be I don't have diabetes. That means an individual has no diabetes. That will be my null hypothesis. While the individual is diabetic patient, this will be your alternative hypothesis. Remember, most of the researchers are doing mistakes in setting up the null and alternative hypothesis. So remember that how to set up the null and alternative hypothesis, that is very, very important. So in this example, look at the type 1 error. Always remember this way, that what is type 1 error? Here in this particular example, that reports are showing that you are diabetes patient, but actually you don't have any diabetes. That means H0 is true. H0 is true. That means I don't have diabetes, but the reports are showing that you are diabetes patient. So this is a kind of error, and that is known as alpha or type 1 error. Okay. Now, who is going to decide this type 1 error? So I am going to decide. If I am the experimenter, if I am the user, then I am going to decide the level of significance, and what it indicates common value. The level of significance, its common value is, most of the time it is chosen as 5%, 1% or 0.1%. For example, 5%. What is meaning of this 5%? So 5% means, if I will have, suppose I have whatever testing I have done, so it is based on alpha equal to 5%. So what exactly it means? That out of 100, if I'll perform such test 100 times, then I can be wrong 5 times. This is the wrong probability, that out of 100, 5 times I can be wrong, but 95 times, out of 100, 95 times I'll be correct. So you can say that this is wrong probability, but at the same time you are specifying that my decision will be correct 95% of the time. When this is when I'm talking about alpha equal to 5%. So now look at this, alpha equal to 1%. What it means that if I'll test the hypothesis, such hypothesis 100 times, then my wrong decision, I can be wrong once, while my decision will be correct 99 times. This is what 1% level of significance. So this particular level of significance or type 1 error or alpha, this is to be chosen by the user or experimenter who is going to perform this. Okay, so that is what your test will be like based on that alpha. Type 2 error, I have already talked about this. This is false negative, probability of false negative, and you have to only look at the type 1 error. Now, who is going to decide alpha? So obviously, whatever hypothesis you are setting up, so the value of alpha will be chosen by the researcher. Now, what is use of alpha? What exactly it will be doing? So this alpha will be giving us critical value. Software will be using this alpha to obtain few things. So critical values are calculated based on this alpha. Okay. For example, let me make it clear that how the decision about diabetes and non-diabetes is taken. For example, this is diabetes and non-diabetes patient. So if I'll make blood sugar test, then if the sugar is let us say 100, this is 100. If it is your sugar content is less than 100, less than 100, no diabetes would be there. But if your sugar is more than 100, then you will be declared as diabetes patient. Okay, so this is what the boundary is there, which decides whether you are in which region, whether you are in this region or in this region. That is decided by this boundary, and this boundary, let us call it as a critical region. So critical region will divide the whole region into two parts, and one part will be supporting the null hypothesis, other part will be supporting the alternative hypothesis. So that is the use of alpha will be for dividing the region in two parts, and that region is known as critical region. So look at this. Suppose this is some actually this is some statistical distribution. Now based on alpha, you can see that the region is divided into two parts. If your value will lie in this region, then you will be rejecting H0. If your value of the test statistic will lie in this region, then you will be failing to reject H0. So that's why the region where you are rejecting the null hypothesis is known as critical region. So critical region is calculated by using alpha. Based on the data and your alpha, this critical region will be calculated. So you must only know this concept, that what is use of alpha. The other things, what is that region and how to calculate that will be taken care by the software is going to take care of that. Now, once again, let us come back to our hypothesis, that when you have the hypothesis like mu is equal to mean weight of female students, suppose it is 62. So your alternative hypothesis can be mu less than 62. That means mean weight of female student in my class is less than 62. So this is one-tailed hypothesis. The upper tail hypothesis will be mu greater than 62. That means you want to check whether the mean weight of female student in my class is more than 62, and two-tailed hypothesis will be mu not equal to 60. So this is what based on your hypothesis, you can have three types of alternative hypothesis: lower tail, upper tail, and two-tail. Depending on situation, we'll see under what situation what is to be done. Now, what will be use of this alternative hypothesis? So I was talking about this shaded region. This shaded region is actually critical region. So, okay. So when your hypothesis, alternative hypothesis, this will be your critical region. When your alternative hypothesis is this type, the critical region would be this side. And when you have two-tailed hypothesis, then critical region will be to both sides. So that is the use of, that means what will be the effect of alternative hypothesis in your decision making. So when you are changing your alternative hypothesis, critical regions are changing and your decision may change. So you must be very careful how to set up the alternative hypothesis. Yes, once again it is shown. So let us now conclude what are the important steps in testing of hypothesis. So first of all, suppose I am working on some research problem. So first of all, what I have to do, I have to set up the null hypothesis and I have to choose alternative hypothesis which is suitable for my particular problem or research problem. Okay. Now, once you set up the null and alternative hypothesis, you will decide which test, which statistic. There are plenty of statistical tests. So you are going to decide which test is used, and based on that, you or the software will calculate the value. Just like in diabetes case, we are going for report, and reports are showing my sugar content in my blood, sugar content in my urine. So that is what we can say is the test statistic which is to be calculated. Then you have see what you have done based on the research problem. You have set up null hypothesis, you have set up alternative hypothesis, then you have taken decision about which test is to be used. Then you have to decide level of significance, that means alpha. So most of the common values of alpha are 5%, that is the commonly used value, but you have to decide. So if your research problem is very critical, then you will choose accuracy, you want more, then your alpha will be 1%. So remember, it is up to you. Then all these things you have done. Now software, use software, and software will give you p-value. Okay, p-value or critical value, whatever it is. So this, you don't have to worry about how to do calculations because softwares are there. Only thing is that you have to decide which test is suitable for your research problem. Okay, so using software, you'll reach at p-value. Based on p-value, you are going to conclude. The conclusion would be like this: if p-value is less than alpha, then reject H0, and otherwise do not reject H0. Otherwise, okay. So this is what is your conclusion. So now whatever will be your decision, whether you are rejecting H0 or you are supporting H1, we can say, based on your decision, you interpret whatever your research problem was, conclude that in terms of your research problem. So interpret the decision of the testing of hypothesis. So these are the steps. These are the steps. These steps should be followed, and in these steps, all the main work will be done by software, but rest of the things should be clear to the researcher, that how exactly we have to proceed once we want to test the hypothesis. So for example, again, I have one example. Here, I'm interested in testing whether the mean number of mobile sets in Indian homes is 3 or not. So what will be my H0? My H0 is mu equal to 3. What will be my alternative hypothesis? Actually, I should set up that mean should be more than 3, because now in the present situation, every home will have more than 3 mobiles. So I can do that one. But if I would have been suppose 2015, if I'm testing this hypothesis in 2015, we know that there were very less mobile sets in every Indian home. So at that time, this hypothesis would have been suitable. So depending on situation, you have to set the alternative hypothesis. Then I'll choose my level of significance. Suppose it is 5%. Now, if you want to test this one, I'll choose sample. That means I'll go to 100 Indian homes and I'll record how many mobile sets are there in each home. So I'll get 100 values. So. Okay. Now, here, suppose you are using Z test. Okay, you are using Z test. So based on Z test, software will give me critical value or p value. So this is your critical value, and this critical value will be used to take decision. So based on the collected data, I have done some calculation. Software has done test statistic. The value of that test statistic was suppose -2. So based on now this computed test statistic value and this particular critical value, I'm reaching a decision that the null hypothesis should be rejected. What was my null hypothesis? Mu equal to 3. So if you are rejecting the hypothesis, then what it means that you are supporting H1. So reject the null hypothesis means this is you are rejecting, but you are supporting the alternative hypothesis. So because this is example I have taken, which was not in recent year. So here the true mean number of mobile sets are less than 3 in Indian household. That was my conclusion. But now if we'll perform the same exercise, then this hypothesis is to be set as mu greater than 3. But anyway, let us p-value approach. So because most of the participants are non-statistician, so don't go in all these things. But I'll say only focus on this, that reject H0 if p-value is less than alpha. What is alpha? Participants, what is alpha? And what is p-value? Who will give p-value? Who will decide alpha? Can anybody tell me? Yes? Are you there? Okay. So actually, let me make it clear. P-value will be given by software and alpha will be decided by you. You are the researcher, so you are going to decide the value of alpha. Okay. Yes, let me go. This is for your reading purpose. Yes. This is the language that should be used, because when you are writing the thesis, you are writing the paper. Proper language should be used when you are giving the decision about testing of hypothesis. So result of testing of hypothesis, in two ways you can give. You will just say fail to reject the hypothesis. Do not say that we are not accepting H0, but we just say that fail to reject the null hypothesis or reject the null hypothesis. These two statements should be written in our conclusion when we are using testing of hypothesis. So correct wording of final conclusion of our testing of hypothesis should be used. So this language is totally incorrect, not accept H0. This is the incorrect way of concluding the testing of hypothesis. Yes. So now I have one example, but before that, just see that in hypothesis testing there are a variety of, as I said, thousands of methods are there. But in that, actually, most popular there are Z-test, T-test, ANOVA, chi-square test. Those are plenty of tests are there, but most commonly used are these tests. Okay, but non-parametric tests, these are most of the time used when categorical or rank data is there. So that is a different topic, that which non-parametric test to be used where. Okay, now let us have one example. Basically, in market research and social sciences, this type of testing of hypothesis will be there. So I have included, instead of directly going for T-test and Z-test, I'm considering the example which is very commonly used in survey analysis actually. So survey analysis is done by market research people or social science people or education people. Okay, so let me make the concept clear. Contingency table. So it is a table which is actually in the matrix form, and some numbers are given here which are known as frequency distribution. Okay, now let us see example, then it will be more clear to you. Just see, this is example of HIV testing. Random sample of 120 college students were taken, and all of them were undergone for HIV test. Okay, now look at this. This is called as contingency table 2 by 2. two rows are there. These are two rows and two columns are there. Okay, so that's why it is known as 2 by 2 contingency table. Now, what this number mean? Look at this. That out of 120 college students, 9 female students, their HIV test came positive. 8 male students, their HIV tests were positive. 52 female students were there. Their HIV test was negative, and 51 male students were there. Their HIV test was negative. So this is distribution of 120 students that is shown in table. So these are frequencies, and that's why now if you sum all these, then their sum will be 120. Okay, so this is frequency distribution. That's why it is known as frequency distribution of whatever test, whatever particular objective you are having. You have performed the test and the conclusions are reported in the table, which is known as contingency table. Now, what is to be done with contingency table? One more example, very common example, it is in statistics. So this is example obviously from European countries. So hair color and eye color, these are the two variables. So you want to study relationship between hair color and eye color. So 6,800 German population, from the German population, 6,800 people were taken, and their hair color and eye color was recorded. So what this number indicates that 438 German people sample was having brown color hair and brown color eyes. What it means, for example, that hair color was fair and eye color was blue for 1,768. So such data, such contingency tables are very common in surveys. Surveys are done by social science people and market research. So this is the general way of representing the people. Now the question is, what is to be done with this contingency table? So here focus of interest is the dependence or association between the row and column variables. So here I was having, suppose, eye color, and here my variable was hair color. So what I'm interested, that eye color and hair color, are they having any relation, any association? So that is my interest. So ultimately I want to study association between row variable. Row variable means eye color, and column variable is hair color. Okay, so it can be treatment response also. Whatever table type of table you are having, that accordingly you are going to have those variables. For example, one more contingency table. So here one clinical trial example it is, and this is surgery, real surgery is done, and they got relief from migraine headache. 41 are such, then 15 are having so and so. So you can have plenty of such examples where you'll find this particular. Now in general, how to set up the hypothesis here? The hypothesis says that two variables are independent, and alternative hypothesis is two variables are associated. So again here, look at the way how the null hypothesis is set up. It is independence of two variables, while the variable are association that is included in alternative hypothesis, right? So here I have given you example of 2 by 2 contingency table, but your table can be in general any number of rows and any number of columns. So that is known as M by N contingency table. So let me have one example here. Real example, it is the example from one market research analysis project. So the attribute was expenditure on beauty products per month, expenditure in rupees done by women on beauty products but per month, and second attribute was marital status. So what is my null hypothesis? That the expenditure and marital status are independent. So everybody knows that marital status, that means those women who are married, those we suspect that those would be expending more amount on beauty products than those which are not married. So we know that. So that is set up in alternative hypothesis. Both the factors, expenditure and marital status, are dependent. We suspect this one, and that is set up in alternative hypothesis. While in null hypothesis, the independence is attributed. Okay. So now in this particular situation, one beauty product company was it, and they conducted survey in which 5,012 women respondents were there. So we asked that how much amount they spend monthly. So now categories are done. The amount spent every month is 500 to 1,000, 1,001 to 1,500. These are the slabs, those are made for the expenditure variable. Now what this particular figure says, one out of 5,012 women students, 1,118 married women, they are spending amount between 500 to 1,000. For example, this one. So unmarried women, 53 unmarried women, they are spending monthly 2,000 to 2,500 rupees on their expenditure on beauty products. Okay, so this is the data, and I want to test whether marital status and expenditure, they are independently distributed or not. So that, see, what are the market policy? The focus, if married women are using more amount on their beauty products, then my focus area should be on the married woman. So that is what they wanted to particularly test. So now, as I said, that I know that for such attribute testing, chi-square test is used. So I have used the software. Okay, so the chi-square statistic software has given me p-value, the software has given me. But what I have decided my level of significance. That means my alpha was 5%. Okay, so I have given the data on contingency table to software. Software has given me this value and this value. Now, can anybody tell me the decision? Because previously I have already talked about how to take decision based on p-value and alpha. Can anybody tell me what will be the decision of my suspicion or my hypothesis? Yes, are the participants active? Anybody? Okay, let me repeat them. Decision, how to take decision? If p-value is less than alpha, then reject H0. Again, I'm repeating. If p-value is less than alpha, then reject H0. So in our case, p-value is less than alpha. Alpha was 0.05. This was our alpha. Okay. So what is the decision? Reject H0. What was your H0? Your H0 was you was rejecting, your decision is rejecting H0. H0 was expenditure is independent of marital status. This was your H0. So what is your alternative hypothesis? That expenditure and marital status are associated. So actually, what is our conclusion? In fact, our conclusion is factors expenditure on beauty products and marital status are dependent or associated, which you wanted to establish in this particular testing of hypothesis. Okay, so associated or dependent, what it means that they have impact on each other. So in general, when you have attribute situation, the research hypothesis proposes, H1 proposes that the two variables are related, while the null hypothesis, it states that there is no relation between the two cross-tabulated variable, and therefore the variables are said to be statistically independent. This is stated in null hypothesis. While in alternative hypothesis, the two variables are dependent or related, that is stated. Yes, one more example I have. The movie type and snack purchase. Are they independent or not? That is to be tested. So what is done actually, data is taken for different types of action movie, comedy movie, family movie, horror movie. How many viewers? So what it mean that 50 viewers who were attending action movie, they purchased snacks, while 75 they were moving action movie, but they have not purchased any snacks. So these are 75. So this is the contingency table, and you can see that this is the 4/2 contingency table. Here, first attribute is type of movie, and second attribute number 1 is this one. Attribute number 2 is purchase of snacks. You can see movie type and purchase of snacks. They are independent and they are not independent. So these are the variety of situations you'll be coming across when you go in your research area. Plenty of things would be there, plenty of situations would be there where you will be interested in establishing the relationship. Okay, so that was example of attribute testing, which is done through chi-square test of independence. So I'm now going for t-test. T-test. There are three types of test. T-test. Sorry, there are three types of t-test. So one sample t-test, then unpaired or independent t-test, and paired t-test. So that is why I was talking about which test is to be used at which position, that is to be decided properly. So even though the t-test is there, there are three situations, three different tests which can be used. One sample t-test. This is also known as two sample t-test, independent t-test, and third one is paired t-test. So one sample t-test. If the sample mean differs significantly from the given population, so this language, I think it will be hard to you understand. So it will be more better to go through examples. So we'll directly go for examples. Okay, let us go for examples and situations. So just see one situation. You want to test whether mu equal to something. Mu naught, I'm specifying, suppose mu equal to 100 versus mu is not equal to 100. Okay, so here you are going to specify the value. In one sample t-test, you have one population, and in that population parameter, mean parameter equal to 100, that you want to establish. So test statistic, that means whatever data you have, that based on data, this test statistic will be calculated, and critical region, rejection region, or acceptance region, based on that will be done by software. You don't have to do anything, but these are the steps that your hypothesis will be of this type. Then based on the data, you'll be having the test statistic, or what we can say the value of the based on the sample data, and based on the sample data, you'll be getting critical value or acceptance or rejection region. So these are statistical notations and things. So let us not bother about this. We'll be directly looking at the example. For example, one example I have taken: social work students have higher grade point average than other students. This is my hypothetical statement. I suspect that one. Okay. So actually there are few assumptions which are required for applying the t-test, one sample t-test. So the variable is interval type, interval level. What it means that whatever data you are having, that is measurable with some instrument, it has some unit. Remember, the variable or data that can be ordinal or categorical or it can be interval level. So it is assumed that all the data, when you are applying t-test, your data should be interval type. Variable should be normally distributed. So I think in HPSS, you have seen some graphs in which normality assumption, whether it is true or not, that is checked through some graphs that is known as QQ plot, or some test is done. So that is again statistical part. Even though you are not doing that one, it won't be that serious. And population variance is known or unknown. Both situations we can apply the test. Now we know that alternative hypothesis can be set up in 3 different ways. Okay, population mean equal to some specified value. This will be your null hypothesis, but your alternative hypothesis can be any one of these 3. Okay, now how to take decision? So based on your alternative hypothesis, decision is to be taken based on p-value and alpha. So repeatedly again I am saying that alpha will be decided by the researcher and p-value will be given by the software. Remember, based on p-value and alpha, you are taking decision about whether to reject H0 or not. But depending on null hypothesis, that means if your hypothesis is less than or greater than type of relationship, then this will be your decision criteria. But if the relationship is not equal to means this type, then your decision rule will be p-value less than alpha, then will be rejecting it. So be careful while using the test. Obviously, software will not give you decision. Decision is to be taken by you. Software will be only giving you the software will be giving you p-value, and you have to take decision. So that's why I must be careful while taking the decision. Yes, now this is one example where you may be interested, some biological person or researcher may be interested that mean height of plant, mu, whether it is 170 centimeter or not. So what he will be doing, he will be generating some sample, he will be choosing 5 plants, he will record the height of 5 plants. Suppose the sample mean is 153 and its standard deviation will be something. Okay, so now your hypothesis is whether mu equal to 170 versus alternative hypothesis mu not equal to 170. So you will decide level of significance, and then see the process. The test statistic software is going to do this one. This will be done by software. Critical region. This will be done by again software or from table, and you will be reaching at the conclusion through p-value or critical region. Okay, so the criteria would be same. So these are the steps which I have included repeatedly. Now, 2 sample problem. This is the second type of situation where t-test you can use. 2 sample problem is used to compare 2 populations. That means whether mean of first population and second population, they differ by d naught, and alternative hypothesis can be less than, greater than, not equal to, whatever it is. Now again, you don't have to bother about this one, but you have to bother about the p-value. Okay, so these things only for your information. So very common or important example we can say. Suppose we are studying weight loss program by using diet and by using exercise. So you are, suppose I want to have weight loss, then obviously I'll be suspecting whether weight loss by adopting diet or exercise should I take. So the question is whether dieters lose more fat than exercise. So my null hypothesis in this case will be mean weight loss, suppose this is mu, for dieters and mean weight loss for exercisers, is it same or not? That I am interested. This will be my null hypothesis. My alternative hypothesis, suppose my alternative hypothesis may be dieters lose more weight than exercisers. This is dieters mean weight loss. This is exercisers mean weight loss. Then, sorry, this should be alternative hypothesis. You can have this type of alternative hypothesis. Dieter lose less weight than exerciser, and you can have one more different type of dieters weight loss is not same as exercisers weight loss. So these are the three situations which you can choose, and according to your position, suppose I am in oppose, I don't want to go for exercise, and I'm only I want to focus on a diet plan. So this one, my alternative hypothesis will be weight loss by diet is more than weight loss by exercises. If this is my plan, then I'll be claiming this one. Okay, so depending on situation, you will be choosing your null hypothesis. So see what is done now. Now weight loss program through diet, 42 women are chosen. Their mean weight loss, their standard deviation is recorded. Then 47 women from exercises weight loss program is taken. Their mean weight loss is taken. Their standard deviation is recorded. And t-test is concluded. T-test is done using software. So the conclusion is that there is statistically significant difference between average fat loss by two methods. So obviously here weight loss programs, they are not equally effective, but one might be more better than the other. That is the conclusion. This is one more example. The faculty in public school and faculty in private school, these are my two populations, and I want to compare that mean salary of faculty in public school and private school, whether it is same or not. And this one I can choose that I know that public school faculties are not given proper salary. So what I can is set up my alternative hypothesis that U1, sorry, private school, they are not giving more salary. So my alternative hypothesis can be this one, mu1 greater than mu2. So depending on situation, you are going to choose the alternative hypothesis. Now, pair t-test. This is the third type of t-test which you can use. In pair t-test, see, the situation is very interesting. Here also the objective is to compare the means, but the situation is that the two means typically represent different, it may be different, representing different times, pre and post. That means the individual would be same. So here comparison of different methods of measurement or two different treatment. Let us directly go for the example. That will be more better. Yes, this is the example. Look at the example, it is quite interesting. You developed new cleaning solution for contact lenses. So contact lenses are used to replace specs, and when you are using contact lenses, cleaning solutions are to be used. So different cleaning solutions are there. So you have developed new cleaning solution. You want to verify that your new solution cleans lenses as well as leading brand. So it is very as effective as leading brand. So you have 14 participants. They wear contact lens for 1 day and clean the lenses. Each participant clean one lens you in your solution, and second lens. You can see that these are the two lenses. This is left eye and this is right eye. So what is done actually? Left eye lens is cleaned with the new cleaning solution, and this one is cleaned with old, you can say, leading brand solution. So this is what pair. This experiment is done on the one individual for left eye and right eye using different cleaning solution. So this is paired observation. That's why it is known as paired t-test, and here amount of variability is reduced. So many things are there, but I just wanted to highlight the situation. So these are the leading brand contact lenses cleanliness and new brand contact lenses cleanliness. These records are there, and then your interest is whether your new solution is equally effective as the old leading brand solution. That is your objective. So here I have not revealed the conclusion, but situation I wanted to highlight. So pair t-test, when it is to be used, when you want to show differences between two time points, you want to show differences between two conditions, or you want to show differences between two measurements, or so on. So pairing should be there when you are using pair t-test. This is one more example. I think you can go through this, but okay. Yes, this is only for your reading purpose. Let me go further, that if you want to extend your testing from two sample problem to k sample problem, then you can go for ANOVA. So remember when to use ANOVA. If you have different k population, then you can go for ANOVA. ANOVA is extension. This is actually extension of t-test. In t-test, two populations are there, population 1, population 2. Two populations you are comparing, but in ANOVA, you can test k population. So this is plenty of researchers are coming across these situations and they are using ANOVA, but ANOVA is also should be used carefully. Z-test for proportions. Let us go for Z-test for proportions. So yes, because we have specific objectives. So here you want to set up the hypothesis which is related to proportions, P equal to P naught. Okay. So again, set up the hypothesis, set up the alternative hypothesis. It can be of these three types depending on your situation. You will be choosing two-tailed or one-tailed hypothesis. Then this will be done by software. Okay, this one p-value will be given by software. Only decision you have to take. So rejection region will be specified by the software. Now let us have an example. Yes, market research company claims that it receives 4% responses from its mailing. This is my hypothetical assertion, we can say. So what will be my approach? I want to test this claim. I have chosen 500 surveyed, and I observed that out of 500 survey responses, 25 were received from mail and remaining were received from other resources. Okay, so your hypothesis at this time point pi is equal to 0.04. This was your hypothesis. Okay, and you wanted to test it. So this is 500 example you have taken, and you got 25 respondents from mail. So you have again used software. Software has given you p-value and what you can say critical region. So what is your decision actually? Based on that, your decision is do not reject the H0. So what it means, do not reject H0? So we'll conclude that we do not have sufficient evidence to reject company's claim that 4% response ratings are through email. So this is what you are reaching at your claim, or what hypothetical statement you was doing about your company. Whether that is true or not, that has been established through scientific test. It is not only based on the data, but it is scientific test. And this is the one more situation where the hypothesis about proportions can be of this type. P1 and P2, these are the proportions for two populations, you can say. So your proportion difference between two is suppose something T0. So again, all these things will be taken care by software, but you have to set up the hypothesis, null hypothesis and alternative hypothesis. Okay, now see what exactly you are going to take the decision. So these things will be calculated by software. What you have to do actually, from the first population, you have to take sample of size N1. From the second population, you have to take sample of size N2. And these things will be calculated by software and decision will be done by based on p-value. Now look at one example here. This is the survey for, actually this is example from population census. The main from 20 to 34 years old population, you want to check whether overweight men in 1980 and in 1990, whether they were same or not. Look at this one. Look at this one. H0, what it says, proportion of overweights in 1980 and proportion of overweight in 1990 for the men in 20 to 34 years, is it same or not? And my alternative hypothesis, we know that as the time is going up, overweight problems are there. So I'm setting up the hypothesis that in 1990, proportion of overweight is more than that in 1980. So what is done now? In 1980, 750 sample is taken. Out of 750, 130 were found overweight. While in 1990, 700 men were chosen and 160 out of them found overweight. This is the data that is generated through your sample. Okay. Now you will feed all these things to software and software will give you p-value or z-value. So look at this p-value. It came out based on the data you have fed to software. It is 0.004, which is less than 0.05. And that's why, what is your conclusion? That for men in 20 to 34 year old, higher percent were overweight in 1990 than 10 years old. So this is how very few things you can test using testing of hypothesis. Okay, so I think this was my last slide in testing of hypothesis. And if you have any questions, then you can ask. Otherwise, I can continue the yesterday's presentation related to graphical presentation of data. Is any question based on this? Or if you want to have my email address and mobile number, I have specified it here. At any time point, if you wish to take my help, you can ask me. This is my email address and this is my mobile number.
Dr. Kaka, Rao sir.
Yes, sir. Yes, sir.
Carry on.
Hello.
Yes.
Thank you very much, ma'am. You have focused on every aspect related to the testing of hypothesis, and after this enriched research guiding lecture, researchers will find the way how the data can be collected and in which manner we can analyze the data up to conclusion. And while doing so, different statistical analysis, ma'am, you have focused, and in which way we can collect the data, analyze the data, what steps can be taken on, and in which manner we can analyze the data with perfection. And that research will continue to the theory, because hypothesis is the previous step related to the research. After this hypothesis, the theories will be supported, which theory will be accepted. It will be having more support from all fields of the research, and the people will take the reference of the theory. The hypothesis is but one step of the theory. So thank you very much, ma'am. You have focused on every aspect related to this, and the researchers will be easily doing their research and will utilize the important steps, formulas, and all the aspects related to testing of the hypothesis, which is the backbone of the research. Thank you, ma'am. So here I would like to express deep gratitude as well as Rajarshi Shahu Mahavidyalaya
Excuse
on
me,
behalf of
sir.
the.
Excuse me.
Yes.
If we have
Yes.
5 to 10 minutes, can we go through the graphical representation? Some important points I wanted to highlight. If we have time.
Why not? Why not, ma'am? I have heard from Phule sir that on the day before yesterday, you have had some technical problem.
Yeah,
Okay, ma'am,
yeah.
you can, Phule sir,
Yes,
can
yes,
we
yes.
allow ma'am 10 minutes time for the previous day's
No.
presentation, because she feels that something has been left from the discussions and guidelines. This is the important character of a very good teacher. And ma'am, I think that chairman of today's session, our chairman of research committee, Dr. Phule sir, will allow to do so. Yes, sir.
Okay.
Carry on, ma'am. Carry on. No
Thank you,
problem.
thank you.
Okay.
So I'll continue
thank you, sir.
from my
Yes.
previous last slide
Yes,
where I was.
yes, ma'am. You can
Problem.
continue, ma'am.
Yes,
Okay,
sure.
okay. I will express the vote of thanks later on, ma'am. Okay.
Yeah, sure.
Okay.
Somewhere I think pie chart. Have we discussed pie chart yesterday? Let me, okay, but just let me, because I have less time, I wanted to go for Pareto chart. Okay, so I'll not discuss all the things, but I just want to, I think that plenty of researchers can use this Pareto principle. So I just want to go discuss Pareto chart, because rest of the charts are very common. You can get help from other YouTube or some Google also you can do, but let me highlight the Pareto chart where we can use Pareto chart. So this principle states that you can highlight few causes which are observed to be very effective or sensitive. Among lot of causes you want to highlight, very few of them are really affecting your study, so you wanted to highlight that. So actually this is known as 80-20 principle. So in general 80% of the problems are only due to 20% of causes. This is the principle, 80-20 principle. For example, in software industry, 80% errors are caused by 20% bugs, or 80% crimes are committed by only 20% criminals. So that is what 80-20 principle we can focus on. So this Pareto chart will be looking at similar to bar graph, in which atoms are ranked according to their frequencies. But let us see one example directly. Just see this particular example, that quality analysis in textile industry wants to identify most significant causes of defect for their product. So the product is shirt, and the shirt defect, type of shirt defect, different due to different defects, the shirts are rejected. For example, button defects, pocket defects, collar defects. Different types of reasons are there for rejection of your product, which is shirt. So this is the data. Suppose you number of shirts, 9 shirts are rejected due to button defect problem, 28 shirts are rejected due to pocket defect problem, and such data suppose you are having, and now you want to analyze it through Pareto analysis, and you want to highlight, you want to focus, you want to minimize the defects. So where you want to focus? Will you focus on all the type of defects? No, you have to focus only on 80% of the defects. So let us see this particular chart. We can see this is the Pareto chart that can be drawn in different software, like you can use Excel software, you can use Minitab software, you can use SPSS software, you can use R package. This one is free, R package is free. You can use Python. This is also free. So the Excel is always available in our laptops. So these are paid software, Minitab and SPS. Okay, but Pareto chart you can draw. This is very important chart which will be leading us to focus on which types of defect you should focus. So look at this, it has different axes. So x-axis is representing type of defect, which is sorted. You can see this is sorted on type of defect. So most important 51 defects are due to cut defects, 45 defects are due to color problems. So these are number of shirts we can say, but look at this particular axis. This particular axis represent cumulative percent. So what we can see, if you want to control 80% of the defect or 70%, let us look at this one. This is 75%. If you want to control, you want to focus on 75% defect, then look at this, that you don't have to look on all these types of defect. Only focus on these three. What are these three which are contributing 75%? You can see that this is accounting 75% of the defects are caused by only three types of defect, that is pocket defect, then
सर मॅडमचा आवाज येत नाही.
Rao sir.
hello, sorry. Just let me conclude. Actually, I know that you don't have sufficient time. Let me conclude this particular example and then I'll stop.
Okay,
So look
okay.
at this, that this
Yes,
is the data on murders in India in 2020. So with different motives, murders are done. So these are the different types of motives I have taken. Disputes, personal enemy, gain, love affairs. These are different types of motives due to which murders were caused. So here percent motives, that means you can say 40% murders were due to dispute, family disputes. We can say 25% of the murders were due to other motives, or you can say love affairs. Due to love affair, around 10% of the murders are done. So if you'll perform Pareto chart, then you will identify that most frequent motives where one should focus on, it is family disputes and personal enemy, which are causing around, you can see again, if I'll put bar here, they are causing around 78 or 80% murders, right? So most of the murders are due to these three reasons. So the Indian government should focus on solving the disputes and personal enemies. What is to be done with this for Indian people? That should be done by the government. So these were other box plot and other plots I have included in my presentation. I am sharing whole presentation with you, and if some part is if you are not getting, I think I have included plenty of things in my presentation. Bivariate data, how to represent it, how to model it, scatter plots are there. Then these scatter plots help us to fit the regression model. So plenty of example also I have included. So yesterday I could not complete it, but I think due to time constraint, because it's 3:30 and you might have next session. So I'll stop, but I would expect all the participants, at least you go through the PPT. It was designed for you, it was prepared for you. So make use of that. And what is my aim actually, that I wish that all the researchers should use more and more statistics. They use it correctly, use it effectively, and reach to your objectives through statistical tools. So this is the objective of this research methodology course. So I hope that all the participants have gained some knowledge, at least some knowledge through this presentation, and go through the PPT. And all the best wishes for all the participants for their research or their career. Is that okay?
Okay, thank you, ma'am.
Okay.
Rahul sir. Rahul sir. Unmute kara.
Hello, Dr. Sir.
Vote of thanks.
Okay. It's my pleasure to express the vote of thanks. As we know, Madam has focused on the testing of the hypothesis as well as the previous day's contents, which were left due to some technical problems. Kamalja ma'am, I'm very much grateful that you have completed the previous day's work even. So you are very much worried about the research work as well as the candidates who have attended this particular workshop, that they should not get any problem in the future when they are doing research. So I am wordless, ma'am. Thank you very much. I am thankful to all the expertise, then the Kamalja ma'am, who is present here as resource person, then chairman of our research committee, Dr. Phule sir, who is also the head department of geography, and he is guiding to all of us all the time. Thank you very much, sir. And lastly, I would like to express thanks to all the attendees as well as Rajarshi Shahu Mahavidyalaya and Principal Dr. M.H. Gavane sir, who has given this opportunity to all the attendees. And I am thankful to the research committee as well as the Western Zone, Pune. Thank you very much, ma'am. Thank you very much to all of you.
Actually, I also would like to thank Principal Dr. Gavane sir, then Taide sir, and Phule sir for giving me this opportunity to interact with the researchers, young researchers. So thank you so much for inviting me and giving me opportunity. Thanks again.
Okay. No mention, ma'am. No mention.
Yes.
Ma'am, already I have sent you one Google form. Get you?
Yeah. I have received. I'll fill it and yes, submit it.
Yes. Okay, ma'am. Okay. Okay. Once again, thank you, ma'am.
Okay. Thank you.
Vishwanath ji.
Yes, sir.
Okay.
Fine, sir. Thank you, sir.
Okay.